Hello students, welcome to yet another lesson. I'm your teacher Alice, and in this lesson we shall look at Form 3 Chemistry Chapter 3. So Chapter 3 is the Organic Chemistry 1. So we are starting on Organic Chemistry, and since we have another part of Organic Chemistry in Form 4, we are going to call this part, or the part we are looking at, Organic Chemistry 1. Okay, so this is the first part 1, and we are going to define what is organic chemistry. And we say organic chemistry is a branch of chemistry that studies carbon compound excluding its oxides and carbonates. So we look at carbon, the carbon compounds excluding or except the oxides and carbonates of carbon. Okay, carbon, it is unique due to its ability to form long chains and rings. These chains are known as hydrocarbons. We are going to see what are hydrocarbons. So it forms long chains, or what we call the long rings, when it combines with other compounds. Then we say carbon is tetravalent. It is able to form stable covalent bonds with itself. One, it can form covalent bond with itself, and also other many nonmetals. For example, hydrogen, it can form covalent bonds with hydrogen, nitrogen, oxygen, and also halogens, to form a variety of compounds. So when carbon form covalent bonds with all these nonmetals, we form other carbons that we are going to give, or we are going also to name them. The reason carbon can form covalent bonds or stable covalent bonds with other metals is as follows. These are the three reasons. One, carbon uses all the 4 valence electrons to form 4 strong covalent bonds. So that is the first reason. It forms, or it uses all the 4 valence electrons to form 4 covalent bonds. Second, carbon can covalently bond to form 1 single bonds, double bonds, or triple covalent bonds with itself. So we can have single bonds between carbon-carbon atoms, and we can have double bonds and also triple bonds between carbon-carbon atoms. Then carbon atoms can covalently bond to form very long chains or rings. Okay. Then when carbon covalently bond with hydrogen, it forms a group of organic compounds called hydrocarbons. So the hydrocarbons are formed when carbon covalently bond with hydrogen. So let us look what are hydrocarbons. So hydrocarbons, and this is what we are going to measure in, are a group of organic compounds containing or are made up of hydrogen and carbon atoms only. So if we have organic compound that have carbon and hydrogen only, this is what we call hydrocarbons. You can see from the name hydrogen, carbon, carbons. So we have these elements, only hydrogen and carbon. That is a hydrocarbon. Then, depending on the type of bond that exists between the individual carbon-carbon atoms, hydrocarbons can be classified into three. That is depending on what? The bond that exists between two carbon atoms. So the first classification, we call it alkanes. So what are alkanes? Alkanes, these are saturated hydrocarbons with single bond between carbon atoms. So we are only having a single bond between carbon and carbon atom. The other one, or the other classification, is alkenes. So alkenes, these are unsaturated hydrocarbons with at least one double bond between carbon atoms. So it can be one double bond or it can be two or more. So, but at least one, if it has only one, it shall be an alkene. Two, it shall also be an alkene, but different naming. According to the nomenclature, we are going to see that. The third classification will be the alkynes. The Y, alkynes. So these are unsaturated hydrocarbons with at least one triple bond between carbon atoms. That is three. Triple means three. So alkynes has at least one triple bond between carbon-carbon atoms. So those are the three classification of hydrocarbons that are formed according to the bond between carbon and carbon atom. That is alkanes, alkenes, and alkynes. These are the three types of hydrocarbons we are going to look at, and this will be the organic chemistry one. So now let us begin by looking at the alkanes. We start by looking at the nomenclature. Nomenclature is the same as naming. So how do we name or how do we classify alkanes? How do we name alkanes? So alkanes are hydrocarbons with a general formula. So we have a general formula. We call it a functional group. That is CnH2n plus 2, where N is the number of carbon atoms in that molecule. Okay, we are going to see that the carbon atoms are linked by single bond to each other and to hydrogen atoms. So we saw that they are saturated hydrocarbons with a single bond between carbon and maybe hydrogen, or maybe carbon to carbon. So the first, we are looking at the alkenes, and these are the first 10 alkenes according to the nomenclature or how we name them. So the first one we are going to look at, we have a table here, we have the name of the alkene. The next one is the molecular formula. We also have a condensed formula and an open structural formula of these alkenes. We start with the first one, we call it methane. It has one carbon atom. So this one carbon atom will be attached to how many hydrogen atoms? 4. So we have CH4. That is the molecular formula of methane. Its condensed formula is still CH4, and we can see its structural formula, its open structural formula. You can see carbon bonded to hydrogen, to one hydrogen, to one hydrogen, to one. So one carbon atom bonded to 4 hydrogen atoms. That is methane. Let's look at ethane. This is a hydrocarbon or an alkane with 2 carbon atoms bonded to 6 hydrogen atoms. So we have C2H6. This is also the condensed formula, and the structural formula. We can see the first carbon atom is bonded to 3 hydrogen atom, then the fourth bond to carbon, and the second carbon is bonded also to 3 hydrogen atoms. The third one is the propane with 3 carbon atoms, butane 4 carbon atoms, pentane 5 carbon atoms, hexane 6 carbon atoms, heptane 7 carbon atoms, octane 8 carbon atoms, nonane 9 carbon atoms, and decane 10 carbon atoms. So there are so many, the chain continues. So these are just the first 10 alkanes, and you can see their open structural formula. So when you want to write the correct structural formula of an alkene, you just need to know the name. For example, if it is decane, it is 10 carbon atoms. So you just write the 10 carbon atoms bonded by a single bond from carbon to carbon atom. So since there is no double bond or triple bond in alkenes, then you can just join the carbon and the hydrogen using the single bonds. Then that one will give you the number of hydrogen atoms that are present in that alkane. So it is very simple to know the number of hydrogen atoms when we write the structural formula. So we are going to see the difference between the molecular and structural formula in our next lesson. But up to that point, these are the first 10 alkanes according to the nomenclature or the naming method of these alkanes. So methane, ethane, you are required to know them as they follow each other, and from maybe you can maybe get an acronym or anything that will help you to remember them as they follow each other. So that is about alkanes. So in the next lesson, we can still look at the general formula and the structural formula. Okay, so the general, or what we are calling the molecular formula of a compound, shows the number of each atoms or of elements making that compound. So it shows the number of each atoms of the element. So for example, if it is decane, it has a general formula C10H22. This means there are 10 carbon atoms and 22 hydrogen atoms in a molecule of decane. So that is what we call the general or the molecular formula. What is the difference between now the general formula from structural formula? The structural formula shows the arrangement or the bonding of atoms of each element making the compound. We have seen from the table, we have the open structural formula. It is showing the arrangement of carbon and the bonding, that is carbon to hydrogen, carbon to carbon, of each element making that compound. Decane has the structural formula as shown in the table. We have seen that in the last slide, meaning the first carbon from left to right is bonded to 3 hydrogen atoms and 1 carbon atom. The second carbon atom is joined or bonded to 2 other carbon atoms and to 2 hydrogen atoms. You can go back to that and look at it again to see the difference between the structural and general formula. So the structural will show the arrangement unlike the general formula. And so we have, since carbon is tetravalent, each atom of carbon is in the alkane must always be bonded using 4 covalent bonds. We have seen that since it is tetravalent, it must be bonded to 4 covalent bonds, single bonds. So since hydrogen is monovalent, each atom of hydrogen in the alkane must always be bonded to using 1 covalent bond. So also that one we have seen from the table, the previous table. The hydrogen is bonded by 1 covalent bond to carbon. Okay, so that will mark the end of our first part 1, and we shall continue to look at alkanes in our part 2. So do not forget to subscribe. Let us meet in the next lesson.